Hi, I'm Paul Kilgan from GK Tuition, and in this video I want to talk to you about coordinate geometry. Now the question that I've chosen to go through here is 2018 Paper 2 Question 2. In this question we're given a triangle and P and R are vertices of the triangle, and we're told that V is the midpoint of P and R. Since we've been given the coordinates of P and the coordinates of R, we can just use our midpoint formula to find the value of V. So in my midpoint formula for my log tables is x1 plus x2 over 2, y1 plus y2 over 2. In this case I've labelled this as my x1, y1 and my r as my x2, y2. So you should always list out the information you're going to sub in. x1 equals 7, y1 equals 10, x2 equals 11, y2 equals 4. I'm just going to take that information and plug it into my formula. If you sub it in, your value ends up as 9, 7. So the point V has the coordinates 9, 7. Okay, for part B, we're asked to show by using slopes that UV is parallel to QR. So you should realize that if the lines are parallel, then the slopes are equal to each other. So the first thing you need to do is get the slope of UV and then get the slope of QR. And they should end up being the same thing. So in this case, again, I've labeled it my x1, y1 is 4, 6. My x2, y2 is 9 and 7. The formula for slope is in your log tables. The slope is y2 minus y1 over x2 minus x1. And if you just sub in your values there, your slope works out as 1/5. If I do the same thing with QR, the x1 is 1, y1 is 2, x2 is 11, y2 is 4. If you sub that into the same formula again, it works out as 2 over 10, which is 1 over 5. So the slope of UV is 1/5, the slope of QR is 1/5. So I can now conclude that the slope of UV is equal to the slope of QR, so therefore UV is parallel to QR. This just means that they're parallel. That means that UV is parallel to QR. Okay, so for the third part of this question, we're asked to find the area of the triangle PQR. Now the first thing that might come into your head is to get half the base by the perpendicular height. But I can't do that in this case because I have no real means of working out what the perpendicular height is. Remember, this is not a right angle triangle, so it's going to be very difficult to use half the base by the perpendicular height. In a triangle like this, the easiest way for us to get the area is to use this formula from our log tables. The area of a triangle is a half times the absolute value of x1, y2 minus x2, y1. Now you'll notice that there's an x1, y1 and an x2, y2, but there's no x3, y3. So I'm only including 2 coordinates in that formula. Because in the log tables, it says you can only use that formula if the coordinates are O, P, Q. Now the P and the Q are irrelevant. They're just random letters they've assigned to points. But O refers to the origin. You can only use this formula if one of the coordinates is the origin. Or in other words, the point 0, 0. So before I can use this formula, I need to do a translation. I need to basically move this triangle. So what I'm going to do is I'm going to take the point Q and I'm going to move it to the origin. I'm going to move it to the point 0, 0. So I just need to consider, what did I do with my x value? What did I do with my y value? Well, the x value of Q is 1. In order to get from 1 to 0, I must have subtracted 1 from the x value. If I had 1 and I subtracted 1, I'd be left with 0. And with the y value, I'm moving from 2 to 0. Obviously, to move from 2 to 0, I must be subtracting 2. Because if the coordinate was 2 and I subtracted 2, I'd be left with 0. So, I need to move Q minus, I need to move it, let's say, down this direction. If I move this point to there, I'm also going to have to move this point the same direction again, and this point the same direction again. So basically, I'm just taking the 3 vertices, or the 3 corners of the triangle, and moving them. If I move all 3 of them the same distance, the area of the triangle is still the same. It's in a different place, but the area will be the same. So I'm going to move both of these coordinates. I'm going to subtract x, and I'm going to subtract 1 from the x and subtract 2 from the y. So let's take the coordinate P. I'm going to subtract 1 from the x and subtract 2 from the y. If I subtract, it's 7 minus 1 will give me 6, and 10 minus 2 will give me 8. So I'm going to move the point P to the coordinates 6, 8. And with or, I'm going to subtract 1 from the x and subtract 2 from the y. So 11 minus 1 is 10, 4 minus 2 is 2. So the point OR is going to move to 10, 2. And now I'm happy enough, I'm going to be able to sub into this formula. In this case, we'll ignore the origin. This will be my x1, that'll be my y1. This will be my x2, that will be my y2. I can sub those values into the area, and it'll be relatively straightforward now to get the area of the triangle. So I want you to try it yourself, and then I'll do it from the top. Okay, so now I'm going to get the area of this triangle, the coordinates of the triangle being 0, 0, 6, 8, and 10, 2. It's the same triangle as PQR, it's just in a different place, but its area will be the same. I can ignore the 0, 0 and take the other values as the x1, y1, x2, y2. If you sub into your formula, it works its way down, you end up with a half times the absolute value of minus 68. These absolute value signs indicate that what's within it has to be positive. So because this is a minus 68 within absolute value signs, you just ignore the negative. You can just ignore the negative and take that as plus 68. So I'm just putting normal brackets around it, but instead of considering that to be a minus 68, I'm just viewing it as if it's a plus 68. Because the area of the triangle can't be negative. So now just a half multiplied by 68 gives me 34. So the area of the triangle PQR is 34 units squared. And that's your final answer for part C. Okay, in the final part of this question, we're asked to find the coordinates of S, where S is the image of Q under the translation U to V. Okay, so it's really important that you understand what a translation is. So basically it's given as that symbol. It's U to V with the arrow above it. The translation U to V would move any point from here to here. Or in other words, it moves any point this distance. Every point will move the exact same distance as a point needs to move to get from U to V. So I know that I'm looking for the image of Q under the translation U to V. So that means we're starting off at Q and we're moving the distance U to V. So I'm roughly, based on my graph, the distance from U to V, but we're starting at Q. That means we start at Q and we're going that way. Roughly that distance is the same as that distance. We go up the same amount, we go across the same amount. Now obviously that's a completely rough estimate, but that just allows you to visualize what's going on. The maths here is actually very straightforward. I know that U is the point 46 and V is the point 97. So I need to work out what happens in order for a point to move from U to V. I need to work out what happens to the X value and what happens to the Y value. So let's have a look at this. The X value of U is 4 and the X value of V is 9. So in order to go from U to V, I need to add 5 to my X value. The Y value of U is 6 and the Y value of V is 7. So in order to get from U to V, I need to add 1 to my Y value. So mathematically, if you add 5 to X and you add 1 to Y, that is the translation U to V. And happy days, because I already know that Q is the point 16, which means I'll just use this translation and I'll figure out what S is. So I know that I'm trying to find the image of Q under the translation where X increases by 5 and Y increases by 1. So 1 plus 5 gives me 6 and 2 plus 1 gives me 3. Happy days, that means that S is the point 6, 3. Now I hope this video makes sense. If there's anything there you're unsure of or you'd like me to clarify it, just send me an email or let me know in class and I can explain it differently.